first two problems on the Section 6 homework are using the 3 steps we learned to convert between logarithm form and exponential form and vice versa. So the first one that we have here, we're trying to convert this log expression into exponential form. So the 3 steps involve, number 1, what's the base? Well, the base is the number at the bottom of the log. So that would be a 3. Step 2 says that a logarithm is an exponent, and so we have logarithm is exponent. So our exponent is also a 3. And then finally, the other number, which would be the 27, gives us our logarithm form. And that goes in our answer box. And the second one is just the reverse of that. Same 3 steps, however. We're going to convert this into logarithm form. So again, we say base. In this case, that's the u, goes down at the bottom of the g. The logarithm is the exponent, and that's the m. Then the other thing is the p. And that's what we'll type in our answer blank. Now these involve typing on our calculator. So I will take out my TI calculator and we'll start with a log 2176.3 . Now on our instructions we're rounding to 5 decimal places. Now if you look on my calculator here, this is 1, 2, 3, 4, 5 decimal places. So we're rounding right there. We look at the number past that, which is an 8, and that tells us round the 1 up to a 2. So we would have 3.33772. On the B part, we would have log 0.0094941. And again, to 5 decimal places, we would have negative 2.02255. And for the C part, the ln would be the ln button here, 825.57. And notice you don't have to enter the parentheses at the end. To 5 decimal places, 6.7160, and then that 7 would stay a 7. And for the last one, here's the ln, 0.045633. To solve the logarithm equation, we use the steps that we did in the first 2 problems to convert this from logarithm form into exponential form. In exponential form, we would have the base. The 4 at the bottom of the G is the base. The logarithm is the exponent. Then the other number would be the 4x minus 9. Now we solve that equation to do 4 to the 4th power. I won't take out my calculator and make you watch me type that. That's 256. And we add 9 to both sides. And we get 4x equals 265. We divide both sides by 4, and we get x equals, and we can type that into our calculator. However, notice in the instructions, we're to enter our answer as a fraction or an integer, and the fraction would indeed be 265 over 4. Just what we got when we divided it. And we use the similar process for this one. To change this into logarithm form, we start by writing log. The base is the e. The logarithm is the exponent, that's the x. And then the other number, 4.771. Now we'll take out our calculator and do the log base e of 4.771. That would be the ln of 4.771. Or, if we did alpha and then number 5, log base, we could literally put the e here. Now that would be second, and then divide, then the 4.771. So again, we get the same number whichever way we type it. And to 4 decimal places, that'd be 1.5626. And similarly, we want to convert this into its equivalent logarithm form. That would be log. In this case, the base is 2.273. Now the logarithm is the exponent. So there's the 11t. Then the other number, which is the 4. To compute this, we will again take out our calculator and enter that into our calculator using the green key, the window key, and number 5. The base is 2.273 and 4 is the other number. Now, we're not finished. We've got this number equals 11t. To get our answer, we need to divide by 11. Now notice, I'm going to take my calculator here and divide by 11 simply by hitting divide and 11. Now the calculator knows I mean that number that it just came up with, which I didn't even bother writing it all down, and that is what we need to round to 4 decimal places. Now finally, on number 7, this is like what we've done in the rest of the chapter. We have some data points. Let me point out that we have here 1900 is the X number, okay, starting place. That means this 1950 is really a 50. This is a 60, 70, and so on. So we don't need to enter these into our data list because we are already given the model. That would be really the only reason I would want to spend the time typing all of those into my calculator, is so I could use the regression to find the model. But they've already done that for me. So there's my model. Now, if I needed to, I could type the data in L1 and L2, draw the graph of those dots, and then type my function in Y1 and draw the graph of that to pick out the right answer down here. But I feel like you can pick out the right answer just by understanding the concepts that we've been talking about in the past sections. First off, notice on the A choice, all of the dots are lined up in a straight line. These are not in a straight line. So I know that that is not the right choice. D choice is obviously wrong. You've got dots, you've got a line that doesn't come near matching up with the dots. And that leads me down to the other two graphs. And again, just by understanding what I said on the D part, you should see that the B is obviously not possible because the line is below the dots. Every dot is above the line. The correct answer, C, as you see here, would have some dots below and some dots above the line. So C would be the correct choice. The B choice in the problem says use the function, that means this, to estimate the yield in 2029. So, from what I said in the beginning, 1950 is actually 50. 1900 is the starting place for x's. That means 2029 and 1900 would give 129. So we need to take our function and substitute a 129 for x. That would be a negative 566.101 plus 152.607 ln 129. Now again, I'll go type that into my calculator without making you watch all of that. Now to the nearest whole number, that's what integer means, that would come out to be 176. You see on part C, we're looking for the year, which is X, when we're told that the yield is 54 and the yield is Y. So we want to take our function and use a 54 for Y and set that equal to our model. And solve for x. To solve for x, we need to begin by adding 566.101 to both sides. On the left-hand side, we would come out with a 620.101. And on the right, we would have the 152.607 ln x. We need to divide both sides by the 152.607, and that comes out to be approximately 4.06. Now there's digits after that. I'm not going to bother writing all of those. However, I will also use all of those in my calculation. So when we get to here, we will need to use our magic transformation like we did in the first two problems in this problem set. The ln x means log base e. We're going to convert this into exponential form. Base e. The logarithm is the exponent. So that 4.06, etc., is the exponent. And then that's equal to x. Now I'm going to use my calculator to do e to that power. That comes out to be a 58.17, and then there's several digits after that. However, you notice here we're trying to find the year, so 58 would be the nearest year, and that's 58 years after 1900, which would come out to be 1958.